Day 22. Predict car prices using random forest. Now in this project, we will create a car price prediction model using random forest. The goal is to predict the price of a car based on various features like make, model, year, mileage, etc. Now random forest is an ensemble learning method that's suitable for regression tasks as it combines multiple decision trees to improve prediction accuracy. Now let's go ahead and see how we can implement this particular case. I'm going to go jump into our day 22 folder. As you can see, I have already created a Python file called as day 22, and the first steps would be to import the necessary libraries. Now we will import pandas, which is used for data manipulation and data frame creation. Next, we'll use the train test split, which splits the dataset into training and testing sets. It's available in sklearn.model selection. Next, we're going to get the random forest regressor. This implements the random forest regressor model for predicting prices, and it's available in sklearn.ensemble. And then we'll get the mean square error and R2 score used to evaluate model performance with metrics like mean squared error and R squared, which are available in sklearn.metrics. Next, let's get our data set. Now I'm using a sample data set. You can replace this with a real data set if you have one available. So here I'm creating a data dictionary which represents the sample data set. Now each key represents a feature which is make, model, year, mileage, and price. Now each list contains data for a particular feature. The first one is make, where I have Toyota, Honda, Ford, and others. I have model, Corolla for Toyota, Honda Civic, and others. Similarly, they match to each other. Here, the first car is 2015 Toyota Corolla. The second one is 2017 Honda Civic. Now mileage. The Toyota Corolla has 50,000 miles, the Honda Civic has 30,000 miles, and so on. Price 15,000 for the Corolla, 17,000 for the Civic, and so on. So that's my entire data sample data set. Now first, let's check and convert into data frame. So to convert to data frame, I'm going to use pandas data frame function, which converts the dictionary into a pandas data frame called df, making it easier to analyze and manipulate. And let's print it out to display how it looks like. Next step is to encode the categorical features using one hot encoding, because we have some text over there and we want to convert it into numbers. So to do that, I am going to call the pd pandas.getDummies df and pass columns make and model. So if you see make and model are not numbers, so I want to convert them into numerical values using one hot encoding, and that's what I'm doing here. So df encoded will give us the encoded numbers, so you'll probably print it out and see the values. So df encoded, the resulting data frame where each unique value is make and model, has its own column with a binary indication, 1 if the value is present, 0 otherwise. So that's what this does. Next one is, let's define the features and target variables. So for x, I'll say df encoded dot drop price access fund, because I want to use price as my target, not my feature. So I'm dropping that here, and in my target, I'm just including the price, which is my target variable. So x is a data frame containing all columns except the target variable price, representing the features used for training, and y is the price column, which we want to predict. So moving on, we'll split the training into split the data set into training and testing sets. So I can do that by calling the train test split, pass it x, y, and test size of 0.2, and then the random state is 42 as the key. So this will give me x train, x test, y train, and y test. So moving forward, I'm going to initialize the random forest regressor. It's a model equal to random forest regressor, pass it an n estimators of 100, which specifies 100 trees in the forest, which is a typical starting point, and then random state 42, which ensures the reproducibility by setting a random seed. Now next, training the model. So training the model, I'll say model.fit and pass it xtrain and ytrain. Now the fit trains the random forest model on the training set xtrain and ytrain. The model learns the relationship between the features and the target variable in here. Next step is to make the predictions on the test set. So for this, I'll create a ypred variable, which I'll pass model.predict xtest. So predict uses the trained model to predict car prices for the test set, which is the X test. And ypred will finally store the predicted values. Now, if you want to evaluate, we'll be evaluating on this particular variable. So I'm going to say evaluate the model, and for that I will use MSE, which is mean square error, and pass it y-test and ypred. This calculates the mean squared error MSE between the actual and the predicted car prices. MSE represents the average squared difference between predicted and actual values, whereas we'll also use R2, which is R2 score, which calculates the R squared score, which indicates how well the model explains the variance in the target variable. R squared ranges from 0 to 1, and 1 indicates a perfect fit. So let's see if it's perfect fit or not by printing the mean square error and R squared error. So we can check if MSE, if a lower value indicates better prediction accuracy for MSE, whereas R square score of variable value in closer to 1 indicates the model explains most of the variance in the data. So let's try it out and see if it's perfect. PWD, let's say I'm in 22, perfect, and I can say Python day22.py, run it. It gave me the car data set, perfect, and then mean squared error is 23 1 2 3 4 5 6 23 million 443. So a lower value indicates better precision prediction accuracy. So since the number is so big, it might not be as good. And similarly, R squared score, a value close to 1 indicates the model explains most of the variance. Since it's not close to 1, it's like 0.22, it might be not perfect. So this, the reason it's not as good is because my data set contains 10 items, and if you provide more data to it, it will work better. But this kind of gave you an idea of how to use a random forest regressor on a particular data set to create a model or train the model, and then finally predict it. If you have any questions on this, let me know and I'll get back to you.